So what about hormones in animals? We know that hormones are used to increase weight gain in sheep and cattle and milk production in dairy cows. And some hormones, such as estrogen and testosterone, occur naturally. Generally, these are administered in slow-release form, and their levels are no higher in treated animals than in untreated animals. Before a synthetic hormone can be used, it must be demonstrated that the hormone residues in meat from the treated animals are within safe limits. One of the hormones, a synthetic hormone that's created public concern, is genetically engineered bovine somatotropin, BST. And cows naturally produce bovine somatotropin, which stimulates milk production. We know that genetically engineered BSTD is produced by bacteria and injected into cows to further increase milk production. And milk from cows that have been treated with genetically engineered BST, that's been found to be indistinguishable from the hormone in other milk. Here you see consumer groups are concerned that the injection of cows with BST may cause health problems for humans that consume the milk, but the FDA has concluded that BST causes no serious long-term health effects, and it does not require milk from BST-treated cows to be specially labeled. Some dairies voluntarily label their products, though, as BST-free. So how do we minimize food contaminants? Well, what we want to do is choose a wide variety of foods. If you want to choose organic or locally grown produce, that's one way to do it. Wash and in some cases peel produce. That's usually what I do. Trim fat from meat and remove poultry skin, and choose wisely and consume a variety of fish. So remove fish skin, the fatty material in dark meat, broil, poach, boil and bake fish. This recommends do not eat the lobster tamale or the blue crab mustard to reduce your exposure to pollutants. And here is a picture of how to do some of this. So washing fruits and vegetables can remove or by peeling them or washing and scrubbing with a brush. Reduce contaminates your exposure to pesticides and pollutants. Some washing apples, cucumbers, eggplants, squash, and tomatoes may not remove all the pesticides because they're coated with wax in order to maintain freshness, and so the wax seals in the moisture and the pesticides. Oftentimes you can remove it by peeling. Exposure to chemical contaminants can be minimized by choosing saltwater fish caught well offshore, away from polluted coastal waters, and fish that live near the shore spend part of their life cycle in fresh water are more likely to contain contaminants from runoff, and smaller species of fish are safer because they're earlier in the food chain, and smaller fish within species are safer because they're younger and have had less time to absorb contaminants. So what are some technologies for keeping food safe? We know that food spoils when its taste, texture, or nutritional value is changed by natural food enzymes or microbes that grow in the food, and there are certain techniques used to preserve food, and they work by destroying the enzymes present in food by killing microbes or slowing the microbial growth. FAT-TOM is an acronym to remind us of the conditions necessary to reduce microbial growth. food preservation techniques modify one or more of these factors. So F is for food. We know that certain foods contain nutrients that promote bacterial growth, so we identify those. Acidity, most bacteria grow best at a pH near neutral, so some food additives like citric acid and ascorbic acid, vitamin C, are acids which prevent microbial growth by lowering the pH of food. T for time, the longer foods sit in the danger zone, the more bacteria it will contain. So we know that we don't leave food in the temperature danger zone for more than 2 hours, hence your church buffet or your picnic or your party where you're going to need to keep track of the time your food's sitting out. Temperature. We know high temperatures for canning, cooking, and pasteurization kill microbes, and low temperatures of freezing and refrigeration slower stop microbial growth. Oxygen. In order to grow, most bacteria need oxygen, so packaging that eliminates oxygen prevents their growth. And moisture. Bacteria need water to grow, so some preservation methods such as drying or high concentrations of salt or sugar draw water away by osmosis and prevent bacteria from growing. Some other methods are heating, cooling, drying, smoking, adding salt or sugar for curing. Newer methods, irradiation, specialized packaging, and we know that there are some risks there because during this process some substances may enter foods. Food additives versus contaminants. So an additive is any substance that can be expected to become part of food, and FDA regulates the types and amounts of food additives. And accidental contaminants are unexpected substances that enter our food, and those are not, foods that these might be substances that aren't regulated. So high and low temperature preservation provides appealing and safe food. So cooking, again, kills microbes, destroys most toxins. Remember, no unpasteurized dairy products. And we want to process of heating food to kill microbes. Sterilization and aseptic processing placements. They put food is processed in a sterile way and then packaged using a sterile process. And refrigeration or freezing doesn't always kill microbes, but slows or stops their microbial growth. Here's a cute little picture of a juice box that fits so conveniently in our school lunches, and they are produced by aseptic processing. And the technique heats the foods to temperatures that results in sterilization. The sterilized foods are then placed in sterilized packages using sterilized packaging equipment. And if the package remains unopened, juice and other aseptically packaged foods can remain free from microbial growth at room temperatures for years. What about carcinogens from cooking meat? So PAHs are polycyclic aromatic hydrocarbons, and they're formed when fat drips on a grill and burns and then rises with the smoke and then deposits on the food surfaces. So this can be limited. You can reduce your risk for these carcinogens by using lower fat meat and a layer of aluminum foil to prevent the fat from dripping on the coals and then rising back up in the steam and landing on your food. HCAs are heterocyclic amines. They're produced by burning of substances in the meat. So you want to limit pre-cooking your meat, marinating meat before cooking, cooking at lower temperatures, reduce our cooking time with smaller pieces of meat, and avoid overcooking. So this is really saying you don't want to burn your meats, charcoal your meats, and then eat them. So you can reduce the potential for this by pre-cooking so it doesn't burn on the outside and it's raw in the middle, marinating it at lower temperatures, slower cooking times, and not overcooking. Acrylamide is formed from chemical reactions during high temperature baking or frying, typically in carbohydrate-rich foods. We see the highest levels of this in French fries and snack chips, smaller amounts in coffee and foods made from grains like breakfast cereals and cookies. And there is some science to show that high doses may cause cancer, reproductive problems, and nervous system toxicity. Food irradiation or cold pasteurization, we know that's used in more than 40 countries and used infrequently in the U.S. Because of public suspicion and lack of irradiation facilities. This is where they expose foods to high doses of X-rays or gamma radiation or high energy electrons to kill microbes and insects and inactivate enzymes that cause germination and ripening of fruits and vegetables. Pros and cons. Food additives, we know, produce compounds not present in the original foods, but they are regulated. Opponents claim introducing this food irradiation introduces carcinogens and allows the sale of previous contaminated foods, and that potentially decreases the nutritional value of food. We know that irradiated food is not radioactive. There are studies that say the benefits outweigh the potential risk. Often, if you were to irradiate food, you wouldn't need as much pesticides and preservatives, and it has the potential for improving food safety. And here's a picture of how foods are labeled if they're irradiated. So when properly applied, irradiation increases the safety and shelf life of foods without compromising the nutritional quality or changing taste, texture, or appearance. And they have to be labeled with the Redura symbol shown here and the statement treated with radiation or treated by irradiation. And this symbol is not required on the labels of foods that contain irradiated spices or other irradiated ingredients. What about food packaging? The goal of it is to keep molds and bacteria out, keep the moisture in, and protect foods from physical damages. But what about the substances in the paper and plastic containers? Packaging and dishes can leach that. Can all of this packaging material leach into food? Well, it's regulated by the EPA and FDA, and they apply to the intended use of the product. So, for example, plastics can migrate into food when heated in a microwave oven. That's not always considered. So only containers designed for microwave cooking should be used. So if you are microwaving something, that can leach some of those chemicals from the plastic or the containers into the food. So take it out and put it in something else unless it's specifically designed for that. Bisphenol A from plastics. This is a huge discussion right now. It's the chemical in the plastic used as hard, transparent water bottles, baby bottles, and food containers, as well as the coating inside cans. So some but not all plastic containers are marked with recycled codes 3 or 7 are made from BPA, and there's some concern that the BPA could adversely affect development of the fetus, infants, and children. And the FDA supports effort to eliminate the use of BPA in baby bottles and infant feeding cups and to replace BPA or minimize BPA levels in food can linings. What about modified atmospheric packaging or MAPs? This is a preservation technique used to prolong shelf life of processed or fresh foods by changing the gases surrounding the food in the package. The materials are permeable to gas. It's vacuumed out it's infused with another gas, and the goal is that the lack of oxygen reduces the growth of microorganisms. food additives. They make food safer, maintain palatability, improve color, flavor, and texture. There's different types, direct food additives or indirect, and usually the FDA regulates the amounts and types of direct and indirect additives in food. There's a lot of